Okay, so now we move on to the next part. Okay, so we have now completed the binary number system. Okay, so we spoke about how we convert a decimal number into binary and how do we convert a binary number into decimal. Okay, that part we have completed. Okay, so we have so far completed 2 number formats. Okay, and now we move on to the final, the third number format in computer science. Okay, which is the hexadecimal number system. Okay, so in the decimal number system, the first system that we learned, there were 10 digits. Okay, starting from 0 going all the way to 9, so there were 10 digits. Okay, then we learned about the binary number system, and in the binary number system there were only 2 digits, ones and zeros. Okay, now in the third number system, which is hexadecimal number system, there are 16 digits. Okay, there are altogether 16 digits. Okay, so what are these digits? It starts from 0, goes all the way up to 9. Okay, so you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then for 10, we say A. Okay, so if you can just look at my note, if you can look at the tute over here, for 10, we say A. For 11, we say B. I mean, in the number 11 is represented using B. The number 12 is represented using C. Number D is represented using, the number 13 is represented using D. Okay, number 14 is represented using E, and the number 15 is represented using F. Okay, so in the hexadecimal, you have a total of 16 digits in total. Okay, there is a total of 16 digits, and these digits are, I'm repeating myself again, we start from 0, we go all the way to 9, and then we go from A to F. Okay, so A is for 10. Okay, then 11, 12, 13, 14, 15, and 15 is equal to F. Okay, so this is what we call the hexadecimal number system. Okay, right. Okay, so let's go again in the same order that we have been going for the previous number systems. Okay, so how do we convert a hexadecimal number? Okay, if I were to give you a hexadecimal number, how do you convert it into decimal format? Okay, now before we look at that, let's first remind ourselves that when you write a hexadecimal number, say for example, you write a number like this. Okay, let's say you write a number like this, 101 or 101. Okay, now there are 3 ways that this number can be seen. Now in computer science, this number can either be a decimal number, it can be a binary number, it can even be a hexadecimal number. You get it? So it's very important that you write the base so that the person who's reading it, the examiner who's reading it, okay, knows what type of a number you are referring to, which number format are you using. Okay, so if you put over here 16, when you put base 16, the person who is reading it immediately knows, okay, this is a hexadecimal number. Okay, so the base is very, very important. Okay, right. Now, if we are to look at the first part, we are taking the number that we are taking over here is 21 or 21 F3A. Okay, the number that we have taken is 21 F3A, and this is a hexadecimal number, and this hexadecimal number we are going to convert it into decimal format, a format that we understand. Okay, that we directly understand. Okay, so let me write it over here. We are taking hexadecimal to denary or decimal. Okay, right. So what we do is, once again, we write the number. Okay, so as you can see, 21F3A, the number has been written. Okay, and just like how we did for binary, just like how we did for decimal, we start from the right end. We start by giving it position values. Okay, so over here we have our position values. Okay, if you look from this side onwards, we have our position values. Okay, so since we have 16 digits, we take 16 to the power of. Okay, since we are dealing with the hexadecimal number system, and hexadecimal number system has 16 digits, we take 16 to the power of. Okay, so we start with 16 to the power of 0. Okay, so 16 to the power of 0, you should be knowing this by now, is equal to 1. Then we go on to the next step, which is 16 to the power of 1. Okay, which is equal to 16. Then we go on to the next step, which is 16 to the power of 2. 16 to the power of 2 is equal to 256. Then we go on to the next, which is 16 to the power of 3, which is equal to 4096. Then we go on to the next, which is 16 to the power of 4, which is equal to 65,536. Okay, once again, I want you to note something. Okay, if you look, these position values, they keep getting multiplied 16 times. Okay, they are all increasing 16 times. Okay, so 1 became 16, 16 times 16 became 256, 256 times 16 became 4096, 4096 times 16 became 65,536. Okay, so each time by 16 it increases. Okay, by 16 times 16 it increases. Okay, so then again, what we do is we do the same thing as we have been doing previously. We take the value is multiplied by the position value. Okay, the value is multiplied by the position value. So keep in mind, when we say A in hexadecimal, we are referring to, if you look over here, when we say A, we are referring to 10. Okay, now 3 will remain as 3. But when we say F, okay, when we talk about F, we are referring to this value, which is 15. Okay, 1 and 2, it will remain as it is. Okay, so now it's time to start multiplying. Okay, you have to multiply the position value by the value. Okay, so as you can see over here, if we were to start from the there seems to be a problem over here. Okay, so the order isn't correct. Okay, so for example, if you take 15 times 1, 15 times 1 is, it should be actually 15 times 256. So there's a small problem over here in what they have written. Okay, so let me write it below. There is a problem over here. Let me write it below. It should actually be, let's start from the right hand side. It should be 10 times 1, not 15 times 1. It should be 10 times 1. Okay, so there is a problem over here. Just keep this in mind, guys. There's a mistake there. It should be 10 times 1 plus, okay, then 3 times 16, then 5 times, sorry, not 5, it should be 15. So there's another problem over here. It should be 15 times 256. Okay, mistakenly I have put 5 over there. It should be 15. And then we have 1 times 4096, which is referring to this part. And then we have 2 times 65,536, which is referring to this part. Okay, right. So then we write all those values. Okay, we write those, we multiply them, we add them all up, and then we get the denary value, we get the decimal value. Okay, so I'm just repeating myself, guys. There is a mistake over here. I have circled the mistakes that I have made. Okay, there's a mistake here and a mistake here. So it shouldn't be 15 times 1, it should be 10 times 1 because A is 10. Okay, over here it should be not 5, it should be 15 because F is equal to 15. Okay, so just keep in mind about those two mistakes. Okay, and then you add up all the values, and the value that you get after adding them all up is going to be your decimal value or your denary value. Okay, right. Okay, now let's do one more question on our own. Okay, let's take one more hexadecimal number and let's convert it into decimal format. Okay, so let's take the question such as let's take a number like 4, sorry, let's take a number like 43F. Okay, so we'll take a small number like 43F. Okay, so remember, we first get our position values. Okay, so let's get our position values. We start from the right end. Okay, we start from the right end. So let's put 43F over here. Let's put 43F over here. So remember, this is equal to 16 to the power of 0. Okay, from the most right end, if you start, it's 16 to the power of 0, which is equal to 1. Okay, so now we do not need to write 16 to the power of 0 equal 1. We can simply write 1. Okay, so let's just put an equal over here and say 1. This is the position value. Okay, then when we move on to the next one, it has to be increased times 16. Okay, so this is going to become 16. Then when we move on to the next value, its position value should increase times 16. So this is going to become 256. Okay, if you're wondering how 256 came there, just keep in mind, guys, what we did last time. If you look at our tute, as you can see over here, 16, that became 256. If you go one more step, it will become 4096. Okay, just keep that in mind. Okay, right. Okay, so now what we do is we have to multiply the value. So the value has to be multiplied by the position value. Okay, so value has to be multiplied by the position value. So very simple. What we do is we take 4 times 256 plus 3 times 16 plus 1 times, who can tell me F? So for F, if you do remember in our tudes, F is equal to 15, okay? F is equal to 15, so we take 1 times 15, okay? So if we were to multiply this, 4 times 256, it would be 1,000, and then we have to take 6 times 4, 6, 12, 18, 24, so it will be 1,024 over here. 1,024, 1632, 3848, plus 15. So 1,024 plus, let's take it like this, 48, 58, 63. Okay, so finally, how much do we have? 1,027, 1,087. Okay, so finally we have 1,087. Okay, this is so 43F. Okay, so 43F, the hexadecimal number 43F, when it is converted into denary or when it is converted into decimal, the value that you get is 1,087. Okay, so I hope it makes sense. I hope you get it on how we convert a hexadecimal number into decimal format. Okay, right. Then let's move on to the next part. Okay, so I have shown you how to convert hexadecimal to denary. Now let's do it vice versa. Let's take a denary number, okay, a decimal number, and convert it into hexadecimal format. Okay, very easy. We follow the same logic as we have been doing for binary. Okay, so over here, say for example, we want to convert the number 470, the decimal number 470, we want to convert it into hexadecimal format. Okay, the number 470, we must put base 10 over here. Okay, so that the user knows that this is a decimal number. Okay, so if we have to convert the number 470, what we do is, so if you do remember, guys, in binary, when we were dividing by 2 each time. The reason we were dividing by 2 is because in binary we have only 2 digits. In hexadecimal we have 16 digits, so each time we have to divide by 16. Okay, do keep that in mind. Okay, so if we take 16 over here, 16 divided by 470 is equal to 29. Okay, if you check over here, it's equal to 29, and there is a remainder of 6. Okay, 29 times 16. Okay, and there is a remainder of 6. Okay, and if you go one step further, in 29, how many 16s are there? There is 1, and there is a remainder of 13. Okay, there is a remainder of 13. Okay, so if you do remember in binary, how did we write our answer? We went this way, and then we went upwards. That's how we went. Okay, so our answer finally will be 1. Let me take a red color. Our answer will be 1. Okay, remember 13. You don't write 13 in hexadecimal. 13 is equal to D. Okay, so we write 1D6. Okay, so the decimal number 470, when you write it in hexadecimal, it is equal to 1D6. Okay, let's do one more question. Let's take another number, such as, for example, let's take a number like 2,350. Okay, let's take the number 2,350. Okay, so we want to convert this decimal number. We want to convert it into hexadecimal. Okay, this decimal number, we want to convert it into hexadecimal. Okay, so what we do is we take 2,350, 2350, and we divide it by 16. Okay, so if we were to take 2,350 and divide by 16, it has 146. Okay, so we get 146 over here. Okay, let's see how much the remainder is. Okay, minus 2,350. So we have a 14 remainder. Okay, I'm using a calculator to save time, but I don't think in your O-level exams you will be able to use a calculator. You'll have to mentally do it. Okay, so the remainder is 14. Okay, and if we were to divide 146 by 16, I think it is 9. 146, no, it will be around, yeah, 8, no? 146, if we were to divide it by 16, we would get 9. So there are 9 16s, and there would be a remainder of 2. Okay, there would be a remainder of 2. Let me just double confirm. Okay, 9 times 16, if you take it, it's equal to 144. We want 146, so there's a remainder of 2. Okay, now if you look, guys, you cannot divide any further. Okay, you cannot divide any further. Okay, 9 cannot be divided by 16. So let's undo what I just did. Let me undo it. Okay, so we have to stop over here. Okay, so like how we did last time, we write our answer this way and then we go upwards. Okay, so our answer is going to be 9, 2, and remember there is no 14. Okay, there is no 14. So for 14, we write E. So the answer is going to be 9, 2, E. Okay, so the number 2350 when written in hexadecimal is equal to 9, 2, E. Okay. Right, I hope it makes sense. I hope this is working out for you. I hope it's going well for you. Okay, right. Next, what we will be doing is, let's attempt some questions that are there in the tutor. Okay, convert the following binary numbers into hexadecimal. So I'm just going to do only one. Okay, let's take the first one. Okay, this binary number has to be converted into hexadecimal. So we have 11, 00, 00, 11. Let's do it. So we have over here 11, 00, 00, 11. Okay, so this binary number needs to be converted into hexadecimal. Now, directly from binary to hexadecimal is not possible. So what we have to do is we have to first get it into decimal format. Okay, we first get this binary number into decimal format, and then from decimal we go into hexadecimal. Okay, so how do we do it? Once again, we give it position value starting from the right end. Okay, so what we can do is we can give it over here itself. So by now you should be knowing. Okay, so this is equal to 1, this is equal to 2, this is equal to 4, 8, 16, 32, 64, 128. In case any of you are wondering what's happening here, how did he get that far? Okay, how did that 1 come? How did that 2 come? How did that 4 come? Those are position values. Okay, so 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. So instead of writing that, I simply wrote the value itself. Okay, instead of writing 2 to the power of 0, I wrote 1. Instead of writing 2 to the power of 1, I wrote 2. Instead of writing 2 to the power of 2, I wrote 4. Okay, now we should be simply writing the values, not writing, 2 to the power of. Okay, right. Now it's time for multiplying them. Okay, now it's time for multiplying. So you can see we only have to take the ones. We can simply ignore the zeros because the zeros make no difference. Okay, so we need this, we need this, we need this, we need this. Okay, so you can see we have 128 plus 64 plus 2 plus 1. Okay, so if you go down one more step, it will become 128 plus 66, 67. Okay, and if you go down one more step, 128 plus 7 will become 130, 135. So it will become 195. Okay, so this number, this binary number in decimal is equal to 195. Now this number 195, we have to convert it into hexadecimal format. Okay, this number 195, we have to convert into hexadecimal. Okay, so what we do is, I hope you remember, from decimal, from denary, we are going into hexadecimal. Okay, so you may have to spend a few minutes because you're still practicing, you're still new to this. What do? You will have to divide. Okay, you will have to start dividing by 16. Okay, so if you take the number 195, let me put it over here. This number 195, we want to convert it into hexadecimal. Okay, so what we do is we take 195 and we divide it by 16. Okay, so let's take 19. In 19, we have 1, we have a remainder of 3. In 35, we have 2 16s and we have a remainder of 3. Okay, 16 times 2 is 32. Okay, so we need 35. There's a remainder of 3. Can we divide any further? My bad. Can we divide any further? We can't, because the number is 12. You cannot divide 12 by 16. Okay, I'm going to get 0 point something something. So that's not acceptable here. Okay, so you cannot divide any further. So once again, keep in mind, how do we write our answer? We go this way and then we go upwards. There is no upwards here. So our answer in hexadecimal, there is no 12. So for 12, we will be writing 10 is equal to A, 11 is equal to B, 12 is equal to C. So we write C and C3. Okay, so the number 195 is equal to C3. Now there is something very important that I want you to observe over here. look at the length of this number. Look at the length of this number in binary. How long is it? And look how short it is in hexadecimal. Okay, so you see how much of space you can save if you were to write numbers in hexadecimal. Okay, such a number that was in binary, when it is written in hexadecimal, it becomes so much more small. It even becomes smaller than a decimal number. Okay, a decimal number had 3 digits, but hexadecimal is using only 2 digits to represent 195. While binary is using how many? 1, 2, 3, 4, 5, 6, 7, 8. It's using 8 digits. It's using a complete byte. Okay, so later on I'll talk to you the advantage of hexadecimal. This is one point of hexadecimal. One of the advantages is it uses much lesser characters or much lesser digits than decimal and binary. Okay, right, let's try one more question. Let's try one more question. So over here they have told us convert the following hexadecimal into binary. Okay, from hexadecimal we have to go all the way to binary. Okay, so I'm going to take the number, the second one. Okay, I'm going to take the second one, A00. Okay, so let's see how we do this. If we take the number A00, which is a hexadecimal number. Okay, A00. Okay, so remember now we are converting from hexadecimal, we have to come to decimal, and then from decimal we go to binary. Okay, so let's give it position values. Okay, let's start from the right end and give it position values. So we start with 16 to the power of 0, which is equal to 1. Okay, then times 16 for the next position value. Okay, so it will be 16 over here, times 16 for the next position value, which will be 256. Okay, so now if you were to do the multiplications, remember again, you can avoid the zeros. You can ignore the zeros because 0 times anything is 0. So you can simply ignore it. Okay, so all you need to worry about is 256 times A. Okay, so remember A is 10. Okay, so all you have to worry about is 256 times 10. Okay, 256 times 10, which is equal to 2560. Okay, so you have now converted the hexadecimal number into decimal. You have now got 2560. Now from decimal, you go into binary. Okay, so we have the number 2560. We now need to get this into binary. So we're going to get a very long number. Okay, doesn't matter. Let's get started. Okay, so if we take the number 2560, let's divide it by 2. Okay, so here you have 1, here you have 2, you have 1 remainder, here you have 8, and then you just simply put the 0 and remainder is 0. Okay, like I told you guys, if this is an even number, then here it's the remainder is going to be 0. If this was an odd number, the remainder here will be 1. Okay, let's divide again by 2. So over here we have 6, here we have 4, we have a 0, we have a 0, no remainder. Let's go again. Here we have 3, here we have 2, we put a 0, 0. Okay, let's go again. So in 3, we have 1 remainder. This becomes 12, this becomes 6, put the 0, 0. Okay, then we take 16. So in 16, we have 8 2's, just put the 0 below, 0 remainder. Okay, let's go again. So in 8, we have 4, put the 0, 0 remainder. Keep going. Here we have 2, put the 0, 0 remainder. Keep going. In 20, in 2, we have 1, 0, 0 remainder. Let's keep going. So here we have 5, 0. Okay, here we have, how many do we have here? We have 2, and we have 1 remainder. Okay, 5 is an odd number. So you can see immediately the next step becomes, we'll be having a remainder. Okay. Let's go again. So here we have 1, remainder 0. Okay. So how do we write our answer? We go this way and then we go upwards. Okay. So our answer is going to be 101 0 0 0 0 0 0 0 0 0. Okay. So do you see the number A00 in hexadecimal? A00 is equal to 2560. Okay, so in hexadecimal, it took only 3 digits. In decimal, it takes 4 digits to represent that number. While in binary, it takes much more digits to represent the number. So can you already see the problem over here? Binary takes up way too much of space. Okay, and imagine having to read a number like this. If you miss a 0, you might not even notice it. Okay, because so many zeros over here, you may not even notice. If you miss one, you may sometimes count it twice. Okay, these kind of problems can come when you start reading it. Okay, right. So I hope it makes sense. Okay, how we convert from decimal to hexadecimal and from hexadecimal to decimal. And then you also need to know what if they ask you to convert it into binary. If they give you a hexadecimal number and say convert this into binary, then remember you have to go through all three number formats. You have to take the hexadecimal number, convert it into decimal. Then from decimal, you convert it into binary. Okay, if they give you a binary number and say we want this in hexadecimal, then you have to go again in 3 steps. You take the binary number, convert it into decimal. Then you convert that decimal number into hexadecimal. Okay, you have to go through that route. Okay, right. Next, we will be talking about where the hexadecimal number system is used. What are the advantages of it? Okay, I have already given you one advantage. Okay, it becomes very much more easier to read because fewer digits, fewer characters, easy to identify mistakes. Okay, next we'll talk about the use of the hexadecimal number system. Okay,